So we're going to review really quickly how the letter a, or the coefficient a, affects the graph of a quadratic function. So here we have the graph of any quadratic function, ax squared plus bx plus c, and we can see that a is the letter in front of x squared. So our goal is to describe it. When we change a, how is that going to change the graph? So I'm going to go ahead and pull up a graph here. And what we're going to do with this graph is we're going to make a quadratic function. So we're going to type in f of x, and then we're going to make it equal to ax squared plus bx plus c. So ax squared plus bx plus c. And then we are going to add these sliders because what we're saying is a, b, and c can be any single number at all, so it doesn't matter what they are. So our goal is to describe what does a do. So as I slide a, we can see how things change. I'm just going to go hit play for a second. As that is playing, we are going to write down the three things that we see a do to the graph of quadratic. So to summarize, a does three things. The first thing it does is it flips the graph over. We can see sometimes it's up like a cup, sometimes it's down. And when I mean it flips it over the x-axis. Right? It can either look like this or it can look like this. So we can see it's changing based how I change a. The second thing that this is responsible for is making the graph skinny. Like right now, my graph is really, really, really skinny. I can make it even skinnier. It's even more skinny. Same thing up here. Here's a graph. If I make it this way, it's even skinnier. So it can make the graph skinny, and as you saw, if we just change our perspective a little bit, we can make it wider. If I slide it this way, it's getting really, really, really wide. Now we're going to associate some math terminology with that. So when we say that a graph is flipped over, we call that a reflection. And it's reflection if a is negative. So the sign of a is responsible for the reflection. If the a value is positive, it's going to open up like a cup. If it's negative, it's going to be down like a frown. So if any of these negative values for my a, it's always going to be facing down. So aside from the sign, it's the value that makes it positive or skinny or wide. So what we talk about is if the absolute value of a is bigger than 1, so something like 3, 4, 5, 6, 7, 8, 9, 10. That's going to make the graph skinny. So if a is bigger than 1, the absolute value of that is bigger than 1, we call this a vertical stretch. If the absolute value of a is less than 1, then this is going to be a vertical shrink. And again, we don't care about the sign, so something like negative 0.5, the negative causes it to flip over. The 0.5 is less than 1, so that makes it a shrink. So we'll do a quick example here. So if we had something like y equals negative 3x squared, y is equal to 5/3 x squared, and then something like y is equal to negative 1/2 x squared. Based off of the numbers, so when I look at this equation, I should be able to tell how the graph is going to look. Because there's a negative sign, it's going to flip over. If I ignore the sign, meaning if I take the absolute value of a, so get rid of the sign, that just turns into a positive 3. Well, 3 is bigger than 1, so we're going to call that a vertical stretch. Now, what we mean by that is if we compared it to the parent function, so over here on the graph, I'm going to put in the most basic parabola, y equals x squared, and if I set my a value, well, let's just type in the equation actually. If I compare this equation, what I should see is it's flipped over. It's stretched, meaning it's skinnier than this parent graph. So let's see if that happens. So y equals negative 3x squared. Oops. And I can see that it's flipped over and it's definitely skinnier. Now here, there is no negative, so it's not going to be flipped over. But 5/3, that number is bigger than 1, so this is going to be a vertical stretch. So in other words, I should see that graph also be skinnier. So if I just type in something like 5/3 x squared, compare that to the parent graph in green, it is definitely skinnier. With that last one, the negative out front is going to cause it to flip over. So when I'm starting to put this in to my equation, I'm going to start with the negative. Now the 1/2, again, if I get rid of that negative sign with the absolute value, 1/2 is less than 1, so we're going to call that a vertical shrink. And that vertical shrink is going to make it look wide. That's how we see it on the graph. So that's what we should see. It should be flipped over and it should be a lot wider than the parent. So I type in 1/2 x squared, and I can see that it was flipped over and it is wider than the parent graph. So that's your summary of how a, the coefficient in front of x squared, affects the graph of a quadratic.